you can perform some operations on a set. One of them is combining all items in two sets together, which is called set union. You could still remember your mathematics class. When you are dealing with sets, you have some operations like union of a set, intersection of a set, and all that. Okay, so you can also perform all those with sets in Python. All right, so I'm just going to comment all of this out so that we see all these operations in action. Okay, so let's say we have two sets. Let's call this set 1. Okay, let's say set 1 is 1, 2, and 3, right? Okay, let's use this as 3. Okay, and then we have set 2 to be equal to, let's say, 3, 4, 5. So we have 3, we have 4, then we have 5. All right. Now to do union of sets. Okay, so let's say we have set 3. We want set 3 to be the union of set 1 and set 2. So I'm going to say this is set 3. Union of a set is going to combine all the items in the two sets together. To do union of a set, you can say set 1, set 3, you want to make set 3 to be set 1 union of set 2. So set 1 union set 2. Okay. Now if I print this, so I'm going to print set 3. Right. If I run this now, okay, so you see set 3 is combination of set 1 and set 2. Okay. There is a simpler way with which you can write your union of sets notation, and that is using the pipe method. Okay, so you have set 3. Okay, if you could remember, we use this pipe when we are dealing with match case. So you have set 1, pipe, set 2. Your pipe is at the top of your backslash, so you use your shift backslash. Okay, now let's see set 3. Okay, so you see now that this is also the same as this. After union of set, we also have intersection of sets. Okay, with set intersection, it only returns all the items that are present in both sets. Items that are not present in both sets are not returned. So let's see that in action. Let's say set 3 now we want to deal with intersection. So we are going to say set 3, okay, is equal to, now we want to have set 1 intersection of set 2. Okay, now if we run this, set 3 is currently set 2 intersection set 2. Okay, so now you see that we have only 3 returned to our set 3 because 1 is not present in both sets, 2 is not present in both sets, 4 is not present in both sets, 5 is not present in both sets. Only 3 is present in both sets. So the intersection of set is going to return the items that are present in both sets. Okay, so these are one of the areas that Python shine among other programming languages. Okay, Python is very, very compatible with mathematics and dealing with data generally. So Python has the edge over other programming language in all those areas. Okay, so we have another notation for set intersection, and that is using the ampersand or notation. Okay, so for intersection, you can use, rather than using the intersection method, you can just use the ampersand. Ampersand is at the top of your 7, so you use shift at 7. Okay, so we have set 1 and set 2. Okay, if we print set 3 now, so you see we have the same result as intersection. All right, you can also find the difference of two sets. Okay, so difference returns items that are in one set but not in the other set. So let's say set 3 now, or let me comment this out. Let's say we want to make set 3 to be difference of set 1 and set 2. Okay, so we have set 3 to be equal to set 1. Okay, set 1 dot difference. So we use the difference method. We have set 2. Difference is going to return the items that are in set 1 now, but they are not in set 2. So let's run this and see what we have. So we have 1 and 2. 1 is in set 1 but not in set 2. 2 is in set 1 but not in set 2. So take note of this difference with difference of sets. The order with which you pass your sets actually matters. Here now, in this case, we are finding the difference of set 1 from set 2. It's like we are subtracting set 2 from set 1. So it's going to get the values that are in set 1 but are not in set 2. If we run set 2 difference of set 1 now, we are going to achieve different result because set 2 now is our priority in this operation. Okay, so this is supposed to be set 1. So set 2 is our priority now. Okay, so if we run this, what we have as a result, we have 4 and 5. Set 2 now is the principal. Okay, when you are dealing with difference, the order with which you pass your sets actually matters. Okay, so if you want to use a different notation, use subtraction. Right, so another notation for difference is subtraction. Right, so we have a set 1 minus set 2. Okay, we run that, you have 1 and 2 as the element of set 3. We also have symmetric difference. This is different from ordinary difference now. With symmetric difference, it returns all elements that are exactly in one of the sets and not in both sets. Okay, so let's see the difference between difference and the symmetric difference. Okay, with symmetric difference, let's call this set 3 as we usually do. So let's say this is set 1 dot symmetric difference. Okay, so symmetric difference is going to return items that are only in set 1 and only in set 2. So any items that is common to both of them will not be returned. Okay, so let's run this now. We're going to have 1, 2, 4, and 5 because 1 is in set 1, it's not in set 2. 2 is in set 1, it's not in set 2. 4 is in set 2, it's not in set 1. 5 is in set 2, it's not in set 1. But 3 is present in both sets. So symmetric difference does not return that. All right, you now know what sets are and how to create and modify them. You also know how to use some set operations. Like I said and like I've showed you, there are other operations you can do with sets. Okay, so you can practice all of those out yourself at your own convenience. All right, I have a little challenge for you in the next lesson. Okay, so I will see you in the next lesson.